In today's lesson, we'll be learning about special products. Special products are special because they occur in special cases, just like how the slopes and equations of horizontal and vertical lines are special, and you have to go out of your way to remember these cases. There are two shortcuts you can use when squaring binomials. If you recall, squaring involves raising something to the power of 2. And a binomial contains two terms. Remember, a bicycle has two wheels. That's where the prefix bi comes from. Over to the left, we have a binomial because it contains two terms, a and b. It is also being squared. When you have a binomial in the form of a plus b to the power of 2, the answer simplifies to a squared plus 2ab plus b squared. If you actually went ahead and multiplied a plus b multiplied by a plus b, your answer would simplify to what I just circled, a squared plus 2ab plus b squared. Remember, when you square something, it's being multiplied by itself, and that is what's occurring down here. Over on the right, you have another binomial, which is being squared. The big difference is that instead of an addition sign between the two terms, you have a subtraction sign. And because of that subtraction sign, that sign is slightly different than what we had before. So instead of a plus sign, it is now a negative sign. And there you have two shortcuts you can use when squaring binomials. In our first example, we want to expand and simplify x plus 4 to the power of 2. You'll see that we have a binomial because it has two terms and it is being squared. That means you need to use one of the shortcuts. If you look closely, you'll notice that there is an addition sign between those two terms, which means we're going to use the shortcut a plus b to the power of 2, and that simplifies to a squared plus 2ab plus b squared. I want you to compare these two binomials very closely. A represents x and b represents 4. We're going to use these values, x and 4, and we're going to substitute them into our shortcut, which is a squared plus 2ab plus b squared. Let's go ahead and do that. So instead of writing a, I'm going to replace it with x. That gets squared. Instead of writing a, again, I'm going to replace that with x. Instead of writing b, I'm going to replace that with 4. And again, instead of writing b, I'm going to replace that with 4. And I'm going to simplify this. That is equal to x squared plus 8x, why 8? Because 2 multiplied by 4 is equal to 8, and I'm going to have plus 16 because 4 to the power of 2 is 16. I cannot simplify this any further, and my final answer is a perfect square trinomial. And there you go, all the work that is required to use this shortcut. If you don't remember this shortcut during a test, you can just multiply x plus 4 by x plus 4, and you can use the FOIL technique. It will take a little bit longer, but you will get the same answer. In our second example, we want to expand and simplify 3y minus 7x to the power of 2. You'll notice that we have a binomial which is being squared. As well, there is a subtraction sign between those two terms, which means we have to use a shortcut. A minus b to the power of 2 simplifies to a squared minus 2ab plus b squared. I want you to look at these two binomials very closely. A represents 3y and b represents 7x. we're going to use those values, 3y and 7x, and we're going to substitute them into our shortcut, which is a squared minus 2ab plus b squared. Instead of writing a, I'm going to replace it with 3y. Instead of writing a again, I'm going to write 3y. Instead of writing b, I'm going to write 7x. And instead of writing b, I'm going to write 7x to the power of 2. At this point, I need to simplify some of these terms. Let's go ahead and do that. 3y to the power of 2. Everything inside the brackets gets raised to the power of 2. 3 squared is 9. Y to the power of 2 is y squared. Now, this is a little bit tricky, so be very careful. Negative 2 times 3 is negative 6. And then negative 6 multiplied by 7 is negative 42. So what I'm doing here is just multiplying all of the integers. The y and x just remain the same. And last but not least, we have 7x to the power of 2. Remember, everything in the brackets gets raised to the power of 2. So 7 to the power of 2 is 49, and x to the power of 2 is x squared. If you look closely, you'll notice that there are no like terms, and our final answer, therefore, will be 9y squared minus 42yx plus 49x squared. And there's all the work required to expand this binomial, which is being squared. Again, if you can't remember this shortcut, you can just do this the long way. So you can go 3y minus 7x multiplied by 3y minus 7x, and you can use the FOIL technique. We're going to be learning a third shortcut today. If you multiply a binomial by a binomial and they happen to have the same terms within, except you have a plus sign here and a negative sign here, that would simplify to a squared minus b squared. This is called a difference of squares because difference means subtraction or a negative sign, and squares mean being raised to the exponent of 2. So that would be the square it's referring to, and that would be the difference that it's referring to. In our third example, we want to expand and simplify q minus 11 multiplied by q plus 11. You'll notice that we have a binomial being multiplied by binomial. They look exactly the same, except one of them has a negative sign and the other has a positive sign. There is a shortcut we can use, and that is a shortcut that can be used when we have a minus b multiplied by a plus b, which eventually simplifies to a squared minus b squared. This is called a difference of squares. If you look closely at these two sets of binomials, a represents q and b represents 11. So I'm going to substitute in these values into my shortcuts. Instead of writing a, I'm going to write q. That's going to get squared. And instead of writing b, I'm going to write 11. And that is going to be squared. Let's go ahead and simplify that. Q to the power of 2 is q squared. And 11 to the power of 2 is 121. This cannot be simplified any further, therefore q squared minus 121 is your final answer. Now, a lot of students are going to ask me, well, does it have to be in this order? Does it have to be a minus b multiplied by a plus b? The answer is no. It could be a plus b multiplied by a minus b, and you would get the exact same answer. In our fourth example, we want to expand and simplify 4m plus 3n multiplied by 4m minus 3n. Again, you'll notice that we have two binomials which are exactly the same except one of them has a addition sign and the other has a subtraction sign. Because of this, we can go ahead and use the shortcuts. A plus B multiplied by A minus B. You'll notice that I've reversed the order of these binomials. Like I mentioned in the previous example, you'll get the exact same answer. This simplifies to a squared minus b squared. If you look at these two sets of binomials closely, a represents 4m and b represents 3n. Therefore, I can substitute in these values into my shortcuts. So instead of writing a, I can write 4m to the power of 2. And instead of writing b, I can write 3n to the power of 2. Let's go ahead and simplify that. Remember, everything in the brackets gets raised to the exponent of 2. 4 to the power of 2 is 16. M to the power of 2 is m squared. Same thing over here on the right. Everything in the brackets gets raised to the exponent of 2. 3 squared is 9, and n squared is n to the power of 2. I cannot reduce this any further because these are not like terms. Therefore, my final answer is 16m squared minus 9n squared.